Chapter 1.2 Arithmetic Series. A series is the sum of the terms of a sequence. Example, find the sum of the series 1 plus 2 plus 3 plus 4 plus 5 plus ... plus 100. So let's say that we wrote out the series to 100, so S of 100, which would be 1 plus 2 plus 3 plus 4 plus 100. And then let's say that we wrote it out again, but this time we wrote it out backwards. So we have the first term being 100 plus 99 plus 98 plus 97 plus ... plus 1. And then let's say we add those values together. The first term, 1 plus 100, is 101, plus 2 plus 99 is also 101, plus 3 plus 98 is also 101, plus 4 plus 97 is also 101, plus ... plus 100 plus 1 is also 101. So that means that 2 times the series up to 100 equals 101 plus 101 plus 101 plus 101 100 times. So we can write that as 2 times S of 100 equals 101 times 100. But we want to know what's the sum of one of those series. Right now we have 2 of those series. So we divide that by 2. And then we have S100 equals 101 times 100 divided by 2. Hundred and one times 100 gives us 10,100. So S100 equals 10,100 divided by 2. Divide that by 2 and we get 5,050. So the sum of the first 100 terms of this series, 5,050. From this we get 2 formulas for calculating the sum of a series. Both of these are on your formula sheet. The first one, Sn, equals n divided by 2 times t1 plus tn. So the sum of the first n terms in the series equals the n value divided by 2 times the first term plus the nth term. Or Sn equals n divided by 2 times 2t1 plus n minus 1 times d. So you would use the first formula if you know tn, the nth term of the series, and you would use the second formula if you don't know the nth term. Find the value of the 12th term and the sum of the first 12 terms of the series 2 plus 5 plus 8 plus 11 plus ... What do we know? We know t1 is 2. We know d is 3. We're counting up by 3s. We could take the difference between any 2 consecutive and we would get 3. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. We want the value of the 12th term and the sum of the first 12 terms, so n equals 12 in this case. we're trying to determine T12, the 12th term, and S12, the sum of the first 12 terms. Starting with term 12, use the general term for an arithmetic sequence. Tn equals T1 plus n minus 1 times d. We're finding T12 equals T1 is 2 plus n would be 12 minus 1 times d, which is 3. T12 equals 2 plus 12 minus 1 is 11 times 3. T12 equals 2 plus 11 times 3 is 33. T12 equals 35. Next, we want the sum of the first 12 terms. So Sn, use the formula that has T1 and Tn because we know Tn. We just determined that, it's 35. So we can use that formula. So Sn equals n over 2 times T1 plus Tn. We're finding the sum of the first 12 terms, so S12 equals 12 divided by 2 times T1 is 2 plus Tn is T12, which is 35. S12 equals 12 divided by 2 is 6 times 2 plus 35 is 37. Six times 37 gives me 222, so sum of the first 12 terms is 222. Find the sum of 15 plus 18 plus 21 plus ... plus 57. Write down what we know. T1 is 15. D, the difference between two consecutive terms, is 3. 18 minus 15 is 3. 21 minus 18 is 3. N, we do not know. We don't know which term 57 is. We know that T of n equals 57, and we want to know what is the sum of the first n terms. So we need to figure out the n value before we can figure out the sum of those terms. So oftentimes for arithmetic series, you have to use the arithmetic sequence formula first to find a piece of information, and then you can use the sum formula to find your sum. So the general term formula, Tn equals T1 plus n minus 1 times d. Our Tn is 57 here. 57 equals T1 is 15 plus, we don't know n, and plus 1 times d, which is 3. And then solve for n. So subtract 15 from both sides. It gives us 42 on the left equals n minus 1 times 3. Can divide both sides by 3. Divide 3 is 14. 3 divided by 3 is 1, so we have n minus 1 on the right. Add 1 to both sides, and we get n equals 15. Now that we know n, we can use the sum formula. So we have the tnth value, we have that term, 57, and we have T1. So we can use the shorter of the two sum formulas. Sn equals n divided by 2 times T1 plus Tn. We're adding the first 15 terms, so S15 equals 15 divided by 2 times T1 is also 15 plus Tn is 57. S15 then equals 15 divided by 2 is 7.5 times 15 plus 57 is 72. 72 times 7.5 is 540. So S15, the sum of the first 15 terms of the sequence, is 540. The sum of the first two terms of an arithmetic series is 19, and the sum of the first four terms is 50. What are the first 6 terms of the series and the sum of the first 20 terms? Start by writing down what we know. It says the sum of the first 2 terms is 19. So we know that S2 equals 19, and the sum of the first 4 terms is 50. So S4 equals 50. We want to know the first 6 terms, and we want to know the sum of the first 20. So we want to know S20, and we're going to need to figure out T1 and D to get the first 6 terms. Let's write the formula for S2 equals 19. I want to find T1 and D, so I'm going to use the formula for sum of terms that has T1 and D in it, which is the longer one. So Sn equals n divided by 2 times 2T1 plus n minus 1 times D. Then I can plug in what I know. For S2 equals 19, we have 19 equals n is 2 divided by 2 times 2 times T1 plus n is 2 minus 1 times D. Then I can simplify. We get 19 equals 2 divided by 2 is 1. Then we have 2T1 plus 2 minus 1 is just 1. So I have 1D or just D. So 19 equals 2T1 plus D. Let's call that equation number 1. Now let's do the same process for S4 equals 50. Write the general formula for sum of the first n terms. N over 2 times 2T1 plus n minus 1 times D. For S4 equals 50, we get 50 equals 4 divided 2 times 2T1 plus 4 minus 1 times D. And then simplify. 50 equals 4 divided 2 is 2 times 2T1 plus 4 minus 1 is 3D. Multiply the 2 into the brackets. We get 50 equals 4T1 plus 6D. And let's call this equation number 2. Now we have a system of equations. We have 2 equations with 2 variables, the same variables, T1 and D. We don't know either of them, and we want to solve for both of them. So from Math 10C, this is a system of linear equations, which we can solve by substitution or elimination. Whichever method you like is fine. I'm just going to do elimination. For elimination, I have to make sure the equations are lined up. So I have constant term, then equals, then the t1 term, then the d term. So those are lined up the same way. Then I can write one over the other, so I'm going to put the one with bigger numbers on top, but it doesn't matter. 50 equals 4t1 plus 6d, and then 19 equals 2t1 plus d. I want to have the same amount of one of my variables. So typically this means multiplying one or both equations by values so that one of our variables has the same amount. I have 4t1 and 2t1. If I times this equation by 2, I'd get 4t1. Or for my d's, I have 6d and 1d. So if I times this equation by 6, I would get 6d. Either one of those will work. I'm going to times this equation by 2 to get the same number of t1s. Then my new equation becomes 19 times 2 19 times 2 is 38 equals 4t1 plus 2d, and my top equation isn't changing. 50 equals 4t1 plus 6d. Then I decide, should I add or subtract these? I have positive 4 and positive 4. If I added those, I would not get 0. I would get 8. So I want to subtract 4 minus 4 equals 0. I'm subtracting each of the terms in the two equations. So 50 minus 38 is 12 equals 4t1 minus 4t1 is 0. And then 6d minus 2, 6 minus 2 is 4d. Then I solve the resulting equation. I have 12 equals 4d divided by 4, divide by 4. We get 3 is equal to d. Now I need to solve for the t1. So I use one of my equations that I have. My original equation is 19 equals 2 times t1 plus d, or 50 equals 4 times t1 plus 6 times d. I'm going to use this equation because it has smaller numbers. So 19 equals 2t1 plus d is 3 we just determined. And solve for t1. Subtract 3. 16 equals 2 times t1. Divide by 2. 8 equals t1. Now that we have d and t1, we can determine the first 6 terms of the series, and then we can calculate the sum of the first 20 terms. The first 6 terms of the series would be t1, we just said, is 8, and d is 3, so 8 plus 3 would be 11, so 8 plus 11. 11 plus 3 would be 14. 14 plus 3 is 17. 17 plus 3 is 20. That's 1, 2, 3, 4, 5 terms. 20 plus 3 is 23. So those are the first 6 terms in the series. And then we also want the sum of the first 20 terms. We don't know what the 20th term is, so we're going to have to use the longer formula. Switch colors here. Sn equals n divided by 2 times 2t1 plus n minus 1 times d. We're calculating S20, so n is 20, 20 divided 2. 2 times t1, we calculated t1 to be 8, so 2 times 8 plus n, which is 20 minus 1 times d, which we calculated to be 3. S20 equals 20 divided by 2 is 10. 2 times 8 is 16, plus 20 minus 1 is 19 times 3. 19 times 3 is 57. S20 equals 10 times 16 plus 57. 57 plus 16 is 73. S20 equals 10 times 73. So S20 equals 730. That brings us to the end of Chapter 1, Lesson 2.